All right, welcome everyone to today's webinar, Shaping Data with and for Tableau. I am Joshua Milligan and I have with me Bridget Cogley. We are excited to present today about all things data and Tableau. This webinar is hosted by Technion Data Solutions, who graciously employs us, and we enjoy serving clients with all of their data needs. So thank you to Technion for hosting this. Bridget has been here over a year. I have been here almost 13 years, and both of us have greatly enjoyed it. And we're excited for any opportunities to serve you, whether it's through webinars or even in consulting engagements. We love to help people answer questions with their data. So Bridget is going to start us off. Bridget is a Tableau Zen Master, which means that she has been recognized by Tableau Software for her excellence, both as a master of the software and as a helper within the community. She contributes quite frequently through blog posts, so many of you have seen her blog, tableaufit.com. Incredible tips and tricks and beautiful dashboards. Check that out. And Bridget, go ahead and take it away.
Well, thank you. That's definitely a hard intro to follow. So for me, shaping data isn't just about shaping data, but also the collection process, because that is a key limiter to your data. And I'll go through this a little bit more, but I did pull this quote from Mimi Onoha. This was from the IEO conference, and I saw this and couldn't resist, because how we collect data definitely affects its format. Its format then factors into how we use it. And a good example of this is a tree census. I pulled this from the New York City Open Data portal, and they had 3 different surveys, so 1995, 2005, and 2015, and I said, I'm going to use this for Iron Viz. And so I go through this data. I start the process of matching this in Excel, thinking it's going to be a fairly straightforward process. And I realized towards the end of this that there was very minimal overlap, and so any type of longitudinal analysis was really impossible. So I ended up not using the tree census, and part of this is just because of how we collect data, and that influences how we store data, which then ultimately influences how we use it. So a key part of this that we're not going to delve into too deeply is how we collect data, but I definitely want to put that out there in that how we collect it does matter. And so what generates data? And a little bit on the data collection, but when we look at our business, does a visit count? Does a purchase count? How are we tracking things like check-ins? And when we look at space and movement, you know, this might be patient beds. If I've got a patient who comes in through the ER and then moves into a room, perhaps they go into ICU, I can potentially track that movement based on not only on location, but also timestamps. And I believe Joshua may have an example on some of this a little bit later. Another thing for anybody in retail, kind of a navigation around space. I know I've done this before for weather. The other thing that may factor into space and movement is speed. How fast is said item moving? And we may either be able to derive that or we may have a log of that. So thinking about what we collect, how we collect it, what we need, and then also kind of the who within that. So the demographic descriptors and how we describe that data and the interactions that are had between kind of the who's involved. All of that, again, I could probably make a list longer than I am tall on this information, but I just wanted to kind of put a highlight out there of this is some of the stuff that, you know, creates the data, and then how do we manage it? So low-level or transactional data, that's ideal for Tableau. You'll kind of see this again and again. It really allows for near unlimited exploration. It's one of these things of, I wonder, and you start throwing things together and mashing it together, and to me that really represents the beauty of Tableau. It was created as a PhD project from Chris Stolte, and to me it just feels like, okay, I can really look at this, I can do the small multiples, I can really explore this and see what it is that's going on. The next way that we manage our data is through roll-ups, and anybody who's worked in enterprise is very, very familiar with this. In the past, we've done this via Cube. I'll refrain from any further comment on that. However, when you look at most roll-ups, so whether this is we're taking our business and aggregating it at a high level, or we're doing it, we're going to take, every daily interaction and put it as, this is our roll-up, it does limit the exploration. You lose some of that transactional information. I would say typically when you deal with public data, what is also most common is this gets pivoted. So then we get that years at the top. You can see my little frowny face. I'll kind of show you why this makes me sad a little bit later. And then finally, you have what I call program level formats. And this is where we've either taken it from a roll-up or the low-level transaction. Most likely, we've pivoted that because conventionally, most of our analyses programs did favor a very wide but shallow data set. Especially if you come from Excel, you're used to one row is at the level that I need, period. Especially pivot tables and that sort of thing. So really getting adjusted to that, I'm going to make it wide and shallow. However, Tableau prefers it narrow and tall. So keeping in mind those program level formats. And so I'll go ahead and give you a very quick overview of a recent example. So for the Iron Viz, which is a public contest hosted by Tableau, they do this competition. And so I entered the feeder contest and I did the Columbus Zoo. And that example is out there. You are more than welcome to peruse it. I'm going to pull in just different pieces and examples from it. However, the real application is intended for mobile, so feel free to go out there and play with that. But the data that I used was actually in 3 different pieces. So number 1, I needed spatial. They had a really cute map, but it was too much for the phone, so I said, no, 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 this has got to go. And so I went into Google, made some data points, both polygons and points, so therefore I could have kind of here's the regions of the zoo, and then also here's the exhibits within the zoo. One row is equal to a location, but keep in mind there's 2 levels. I've got region and I've also got exhibit. The next is animals. I've got JSON, which was transformed in Alteryx. I probably won't show that as extensively, just in part because I did have to use Alteryx. I did have to engage outside help. And I did not have access to the JSON API. Tableau does connect to the JSON API. However, I did not have access to it because I was going through a website. So Alteryx was kind of my bypass and scraping. And then lastly was the interaction. And what I wanted to do was actually create data. And so by using Google Sheets and Actions, I am creating records every time somebody pushes a button in my dashboard. So let's look at this a little bit deeper. First off is the KML. Again, since Tableau now natively takes in spatial files, it just pulls in this kind of geometry figure. So it says here's a polygon, here's a point, and that's all I need to know now. It's really nice. And I've highlighted the 2 levels that we'll see here soon. One being in blue, the regions, and then the exhibits being in purple. So you can see here's the polygon, here's the point. I have this all in one data set. So if I were to blend this, I would be very limited. We will see that example. Or I could join this, and that's the benefit of being able to join it multiple times. If I wanted to use the blend, I could have these in 2 separate files. That will limit the performance of my dashboard. So without further ado, I'm going to leave the PowerPoint, and this does represent my first time ever using PowerPoint for a Technion webinar. So please don't hold that against me. So what I wanted to do is show the zoo and the regions. So in this example, you can see I have the regions, and you can see I have the exhibits and the count of animals based on exhibit. That is through a join. And I'll go ahead and actually edit my data source. And that way we can see what it is I'm doing here. So I've got my master level data file. And then I've also got the 2 copies, if you will, of the same file. So this pulls it in from a regional level where I'm matching on regions to name. Very simple join there. I'm doing a left join, so I'm only pulling in the data from the data side and not from the map side. So all my extra locations are just getting left off to the side. Same thing here where I'm doing it this time. I've kind of done a string on exhibit number, and then I've done a really nice custom join statement here where I've said, okay, take this, trim it, and only grab the left side of this. So that way I can just pull in what I need. This is a new feature. I want to say it came in with either 10.2 or 10.3, but Joshua can definitely correct me, where I can actually edit my join calculation. If you've not used this feature, It is super, super handy. I highly, highly recommend it. It definitely has saved my skin, as you can see right here, where I was able to do that join statement and not have to go edit my data source. So this was all native within Tableau. And so then going back into this data, you can see where I've got kind of the image I had in mind. If I were to do this with a blend, you can see where I've got kind of my master level data source. You can see here where I've got exhibits. I've got, kind of that regional information, and then I've got my animals. And I'm fairly limited in what I'm able to do. I can't really get in my region. I may end up trying to get creative and say, okay, well, I can do region on color, but it's still not the same effect as if I were to join it. So joins are very powerful. Strongly encourage you to use them. Now with joins and with great power comes great risk. And so I'm going to kind of steal Joshua's trick of what is one row. And so I've actually got this in the story points. And so is it animals? No. Is it visits? No, but I might be getting warmer. And I'm getting much warmer when I say, okay, well, maybe it is, visits, the timestamp, and whether they've been logged or not. And so if I dig deeper in my data, I'll actually find out that when I'm building this, I was able to double and triple stamp almost on the second. So that's why I do have some duplication on records. That was kind of a build error. If I filter out some of the later data, we can see that I don't have that duplication. So that's that kind of one row trick. The final piece I'm going to demonstrate before turning this over to Joshua is some of, again, the data formatting that we do just around kind of the data we get. And so people are probably familiar with my not so much love of public data. And some of that is because of the format in which we get this data. So I've got, for example, what I consider a fairly Spartan data set where it is all measures and no dimensions. And this is extraordinarily common of almost any public data set that seems to be out there. And so if you go and you look and you pull down a lot of government stuff, or you go into academia and you pull down some of that information, you almost always find kind of these tables. And so Tableau does allow me to pivot this, so you can see this is kind of a pre-post where I've pivoted it. Still some limitations, because if you're familiar with Excel tables, they do these terrible, terrible things where they have all these color-coded headers and things like that. And so I did finally do a version in Alteryx where I actually added a few more dimensions. If I wanted to, I could spend the time and do this manually. I do have the benefit of an outside tool, so I went ahead and chose that. So that's kind of a quick view. Joshua's going to give a little bit more detail into how these tips work, as well as some other nice tips as well. Joshua?
All right, thank you, Bridget. I am going to switch to presenter mode here. All right. So what I'm going to do is I'm going to build on that foundation that Bridget laid in terms of the conceptual and some of the ideas there, and then show practically in Tableau why that's important. And Bridget did a good job of showing some of that. I'm going to go through and show some of the different techniques that we might use to reshape things. So Bridget ended there talking about public data, talking about how sometimes you get things that look not so great and they're difficult to work with. Let me give you another potential example. So this is what Bridget mentioned makes her have a frowny face when you see data like this. And you'll often see data like this, where you'll have lots of columns of data, and in a way this is a little bit more human friendly, a little bit more human readable, because I can go through year by year and compare the populations of these two countries here. This is a simplified data set. The real data set, of course, had a row for each country, and that might seem kind of nice because in a certain sense that's what I want, that's what I care about. I care about the population for each country as it grows year by year, and then maybe be able to compare that over time. But this is what's known as a wide data set, and when you look at something like this in Tableau, you're going to end up with something that is not quite so easy to work with. So if I take that country population data and look at it here in Tableau, Tableau reads it just fine. It reads it in the way that we would expect. I'm going to get a column for each year, just like the data set had one column for the countries. And if I look at that in my sheet, I get something similar to what Bridget just showed, where it's a lot of measures and a few dimensions, in this case just one. Now, it's not an entirely unusable data set. I can potentially use something like this, so I can take each measure and put it out on the view. So there's my population for 1960, and I could even split that out by country. And if I want to bring in more than one measure, I can do that. So I can drag it and drop it into the same place as the previous measure, and Tableau will start to use the measure names and measure values fields with a measure values shelf that would allow me to add each one of these years, and I can change the mark type. So if I wanted to get a line, I have some flexibility. I can grab all the years by holding down on Shift and selecting them all, and then drag them all in there. And eventually I can create out a visualization, and it's nice, but this is about the limit of what I'm going to be able to do with data in this shape. I'm not going to very easily be able to add things like trend lines. Tableau is going to complain that I don't have a date or a number for the axis, and why not? Because I'm using measure values, and it's a bunch of different measures. I'm not going to be able to do things like table calculations and running sums and difference year over year. So a lot of that functionality is lost to me, and it's all because of the shape of the data. So what shape do I really want? Well, I don't want this. I don't want the wide data shape. Instead, what I need to recognize is that each column here represents not a different measure. It's all the same measure. It's all population, but each column really is just a value of a dimension, and that dimension is year. So each year slices the population measure, but this shape of data isn't treating it as a dimension. It's treating it as separate measures. Instead, if I had something like this, and this is just a subset of that data, but if I had a field per year so that I could have my dimension values, and then a field per population, which is really the only measure, then I'll have something that's a lot more usable in Tableau. And you'll notice this makes for a lot more rows. Instead of one row per country, I'm going to get one row per country per year. So it is going to result in a lot more rows of data, but a lot less columns. And so some people might worry, well, does that affect performance? Does that mean it's going to take a lot more storage? What's going to happen when I get a lot more rows? Well, the nice thing is that it doesn't adversely affect performance. In fact, it will be faster, because Tableau loves to work in a columnar way, and it loves to roll things up and aggregate them. And if you're using another data engine, such as a server-based database, they love to do that too. So most data engines love to work with data in this shape for performance, for storage. So that's not the concern. The big thing is what that allows me to do in Tableau. So if I were to take this data set, and I'm going to duplicate it, and then edit the copy, right here in Tableau, I have a lot of power for reshaping my data. So it used to be, many versions ago in Tableau, I'd have to do this outside, and Bridget mentioned that there are still a few things that the tools like Alteryx allow you some flexibility, but I love what Tableau continues to do with the data shaping capabilities right here in this data connection screen. So I have all of these columns, and what I'm going to do is I'm going to select that first one, click on the header, and then I'm going to scroll over to the right and hold down on Shift and select the last one. So there are all of the different fields that I really just want to turn into two different fields. One dimension for all the years and one measure for all the populations. So then I'll grab the drop down here on any one of these and say pivot. And when I do that, I get the shape of data just the way I saw it in Excel. The order may be a little bit different here. It's alternating the countries. That's fine. But you can see I'm getting one row per country per year now, and I get the population. And instead of the automatic names, I can come in here and rename these to something that makes more sense. So there's year, which Tableau says that could be a string, but I'll treat it as a number. And so here in Tableau, I can change data types. I can even do calculations. I can definitely do transformations. All kinds of possibilities. I'll call this one population. And now, if I create a new sheet, you'll see with this new data source, I have two dimensions, the country, which I had before, and I have the year, which is great, and one measure, population. So now if I take population and slice it up by country and also by year, you'll see that now I start to get something that's very usable. So I can turn that back into my line chart. I can make year continuous to get an axis. I can do things like add the trend lines. I could do table calculations. I can recalculate trend lines. So I have a lot more functionality just because the shape of the data allows Tableau to work a lot better. Let me show you a couple of other possibilities for shaping data in Tableau. So one thing that Tableau introduced a while ago, but it continues to get updates, is the idea of a union. So a union is the idea that I may have more than one table or file, and they all end up being the exact same structure, or at least a similar structure. So here, for example, I have one text file that is called originals.txt. Has three columns of data: name, occupation, bank account balance, and you'll see some rows of data that are populated with various values. And then I may have another file here that called prequels.txt. And same exact columns, just different rows of data. Finally, I may have another file here called sequels.txt, and again, the same rows of data, or the same columns of data, but additional rows. Now in Tableau, what I'd love to do is I'd love to take all of these different tables of data and treat them as a single table and just append the rows together. So Tableau makes this very easy. In Tableau, what I can do then is create a new data source. These are text files, but this works with almost any type of data source that you have, whether it's file-based or even now server-based data sources are starting to support this as well. So SQL Server, Oracle, there's a list of new data sources supported in 10.3, including Greenplum, IBM DB2, lots of different data sources. And some of those you may say, well, I could create a union before, but you would have had to use custom SQL or something like that. Here in Tableau, it's as easy as drag and drop. So I select my first file, I get a preview of the data, and I start to take my other files. I can create unions of that data, and you'll see that Tableau is just appending the rows of data. Now it does give me an additional field, which is the table name. In this case, that's the file name, and that can be really nice too, because sometimes you'll need to know which file these rows of data came from. And now I've got a lot of different rows of data. I could continue to append, but think of an example of something that may happen within your organization or as you work with data, and that is sometimes you'll have a directory where you maybe get a data dump every month. You're getting a new file, or every week or every day you're getting a new subset of data that represents data for that day. Well, Tableau makes it really easy to not just create a union manually, but you could point it at that directory and tell it, append any files that match a certain pattern. Or an Excel spreadsheet, append any sheets or tabs in that Excel document that match a certain pattern. So you can imagine how this starts to make life really easy. And then if your file was a certain date of the data dump, you would have that in the name here, in the path, or the table. That's never a good demonstration unless you have some sort of an error message show up. And we'll try one last time. So I'm going to remove that. And we'll try a slightly different way of creating it. I'm going to select all the files I want at once by holding down Shift, drag it, and drop it. And it's not happy with me one bit now because I've done something it doesn't like. All right, let's try one last time. There we go. Oh, no, it's not working. All right, let's try a new instance of Tableau. We'll try one last time. This time I'm just going to drag and drop the file, the first file, and then drag and drop the others. No, it does not like that at all. All right. Well, I guess Tableau does not like the sequels. I personally prefer the originals anyways, so I'm glad it's at least taking that one. And if we want to look at maybe the sum total bank account balance between the originals and the prequels, we can definitely see which one is the better option. And of course I could break that out by name as well, and start to visualize that data however I'd like. So unions can be very useful. Another thing that can be very useful that Tableau allows you to do is a cross-database join. And so we've all used joins of data, or at least most of you have, in the past, where you've maybe joined together text files or sheets of Excel documents, or maybe different tables within a database. But Tableau now allows you to join across different data sources. So if you have tables that are located in SQL Server, and you want to join that to Excel data, or data in Access, or Oracle, you can do that. And so, for example, I may have data located in SQL Server. I'll go ahead and sign in and select my database. Here I've got some hospital data. I have a view of patients and visits, and these are very simple views. So, for example, visits simply has the visit ID, the patient ID, and then some dates when the patient was admitted, when they were discharged. And so one thing that I might want to do is bring in the patient data and join that in, so that now I get the patient name and I can see who it was that was admitted and discharged. And then I can take this data and start to work with it. So I'm going to go to my sheet here, but notice before I do that my data source is one record per patient. And that sounds pretty good, because a lot of things I want to know are on a per patient basis. How many patients were admitted? I can get that pretty easily. How many were discharged? I can get that fairly easily. So let's go and see what all I can do with this. So for example, if I want to look by date and say how many patients were admitted on a given date, I can do that. I'm going to right-click, drag and drop my date. So holding down on the right mouse button so that I can select which part or value of the date that I want. In this case, we'll do each date. And I can say how many patients were admitted. And this is where it's important to know that it's one record per patient, because if it was one record per patient, and it is, then I can use the number of records to do that count. I might want to look at this as a bar graph. And that works great. If it wasn't, so if the level of detail of my data was different, I might need to do something like a count distinct of patients. So right-click, drag and drop, do the count distinct, and I get the same answer because of the structure of my data and the detail of my data. But that's why, that's the very first question I always ask of a data source is, what is that level of detail? What's the granularity of that data? Here it's one record per patient, so that works out well. But let's say my question was something a little bit different. I want to analyze how many patients were in the hospital on any given day. So I'm going to create a new sheet here, and immediately I have an issue. I have a dilemma because I have two different dates. I have an admit date, and so I could bring that out here, look at each individual admit date. I have a discharge date, and so I could bring that out and look at each individual discharge date. And what I realize is that I don't have a complete set of dates. So here I'm looking at all these dates are in December, but I see that I've got the 1st, and I've got the 3rd, and the 5th, and the 6th, and the 7th, and the 9th, but I'm missing some dates. Not only that, but I'm definitely missing dates if I consider the fact that I can only use one field at a time for an axis. So if I wanted to create a line chart, I'm going to be stuck saying, well, let's look at admit date only. So here I'll select it as continuous to get that axis. And I can see when the patients were admitted, and I can see how many patients were admitted, but that doesn't tell me how many patients were in the hospital on a given date, because there may have been some that were discharged. And I could bring that in, and we could look at that, and I could start to see, okay, I've got different discharge dates and values. I might want to look at all of this as bar charts, because there are gaps, and the line chart sort of obscures that. But I don't have an easy way of calculating day by day how many patients were in the hospital. Now I could use table calculations and some fancy tricks, and it gets to be a real complicated thing though in Tableau, all because the structure of my data is one record per patient with two different dates. So what if I shaped the data in Tableau to give me exactly what I need? And what I need is one record per day. If my question is how many patients were in the hospital on any given day, then I need a data source that tells me that. What I can do is I can actually create that data source. So in Excel or in some other database format that you prefer, you can easily create this structure of data. And I'm just going to give myself one record per date for that month of December. So we'll start with the 1st. This happened to be in 2016. Then the 2nd, and then of course I don't want to type each date out, so we'll just let Excel build that up all the way down to the end of the month. We'll go to the 30th, and I think that'll be fine. So I have one record per date, and I'll just save this out there. Save. I'll save it not in my union, but I'll save this in my cross-database join. Oh, I saved it as book 1, which is fine, but I'll go ahead and save it as dates. And now I'm going to come back to my data source. I'm going to edit this data source, and I'm going to take this, and now I'm going to join in that Excel sheet. And this is where that cross-database join capability comes in very nicely, because I was working with SQL Server, and of course if you have a DBA, they could maybe build out the data source for you or the SQL statement. But if you want to do it quickly on your own, let's just create that Excel file and then connect to it. And so I'll come in here and go to find that dates Excel file. And when I connect to that, now it automatically pulls in that sheet of dates, and it asks me, how do you want to join this together? Well, what I want to do is I just want to get one record for every date for every visit. And so what I'll do is I'll just use that join calculation feature, and I'll say, let's join 1 to 1. So join calculation on both sides, and that will give me a date, every date for every visit. And now I've got, you'll see I still have my admit date and discharge date. And there will be some dates that may be useful and some that may not. So 12/1 is a useful date because it falls between the admit date and the discharge date. 12/1 here is not as useful because that's before 12/3. So we'll take a look at what we do with that. Let's start a new sheet here. And what I'm going to do is I'm just going to create a calculation that will let us filter to the useful rows of data. So maybe I'll even call it useful rows. And I'll say it's a useful row if the date is greater than or equal to the admit date, and if the date is less than or equal to the discharge date. That way I'll have a record for every date that actually matters. And if I keep those useful rows of data, so we'll filter to the case where that's true, now I have the ability of taking that single date that really matters, and I can put that up on columns. We can look at the continuous value there. You'll notice I do have a record for every date on the calendar, but I also have a record for when that patient was in the hospital. And so if I use number of records, it works just fine because I have a record for every patient for the day that they were in the hospital. And so you can see that I've got a really nice visualization very easily of the hospital patient population. And so if that's what I wanted to analyze, the shape of the data made it very easy. Let's look at one last example that starts to get even a little bit more complex, but really shows the power of what Tableau can do in terms of shaping the data. Let's say that I have this kind of data. I've run across this a few times, and you may have run across this as well. You have data that looks like this. And what I have is a hierarchy that is built into the data. So this hierarchy works like this. I get a record, and it gives me a code and a description and a value. And so the description here helps me understand the hierarchy because I see that that I have food, and the code is A1. So anything that starts with A1 is going to fall under food. And if I append another digit to that one, so if I have A11, fruits and vegetables is a kind of food, and A12, breakfast, is a kind of food. And in fact, if I look at the value here, and then A13, refrigerated food, is a type of food. And then there are additional levels under that, which we'll look at here in a second. So I've got food, and I see the value is 500. Well, it turns out that that is the total of everything that is one level under it. So fruits and vegetables was one level, breakfast was another level, refrigerated food, and if I added all of those values together, I'd see the 500. And then I also see that there are levels under that. So A12 breakfast has one thing under that, which is cereals, A121. And that gives me 50, which is the total there. Refrigerated food, A13, the total is 250. Well, that's the total of A131, cheese and milk, and A132, which is meat. So 20 plus 230, that gives me the 250. Well, this is a very interesting data structure. Turns out it's very useful if what you're doing is writing SQL queries, because you can query this data really quickly to find things that fall within certain categories. It's very efficient for that, but it's very difficult to work with in Tableau. So if I take Tableau here, and let's go ahead and close out this data source and start a new data connection. I'm going to bring that Excel data over here and just drop it into Tableau so that we can take a look at it. So if I have my hierarchy of data, and I go into Tableau and I think, okay, I'm going to work with this, I have one record per hierarchy. So I could look at the description, I could look at the value, that's the Excel file there, but it gets really hard to work with because what am I going to do with this? I guess I could look at it as a bar chart. I could maybe think, well, I want to total things up, but that's not really the grand total because that includes things at different levels. So I'm adding food to breakfast and cereals and cheese and milk. So I can't add all of these things up together and come up with any meaningful grand total. Plus, I don't have any way of seeing the different levels of hierarchy here. It's all on one single level here in Tableau. So this structure of data is not helpful at all. Now you could think, well, I'll use a third-party tool like Alteryx, or I could use something else to reshape the data, and that would be fine. In fact, that might even be useful to do something like that. But what I love is the fact that I can do it in Tableau, just Tableau, not using anything else. It does get a little bit complex, and depending on how many levels you have, it might get a little bit tedious, but it's incredibly powerful to be able to do it right here in Tableau. So what I want to do is I want to come up with a structure that actually gives me just one record for the lowest level detail, and then give me a couple of columns that describe the levels above it. So at the end, I want something that looks like this. Here's what it currently looks like, but what I really want is I want the lowest level description, so fruits and vegetables, cereal, cheese, and milk. I don't want food ever to show up here. That's a higher level. I don't want breakfast to show up. That's a higher level. I just want the lower levels, but then I want a column that's going to help me see what is the hierarchy structure. And now I have values. You can see I could add all of those up, and that's actually going to be meaningful. Or I could add them all up within food, and that'll be meaningful. So this kind of a structure is going to work really well in Tableau. The question is, how do I get from this to this? Well, let's take a look. So using just this database, or just this table, what I can start to do is I can start to join it to itself to start to build out those different levels. And what I can say is if I want to get the lowest level and I want to start to build out what's above it, I can start to do something like this. I can take the hierarchy, join it in here, and I'm going to create a join calculation that says, given the code, what is the next level under that code? Or what's the next level above that code? So for the first level, I'm going to create a join calculation that just takes the first two digits of that code, so left code and the 2, so the first two digits. So if it's A11, we're just going to get A1, and we're going to find out what that first level is. All right, so why doesn't it like that? Oh, it doesn't like code. Why not? Code hierarchy 1, because that's the table we're using. Alright, so the left code in that hierarchy 1 table, the first 2 digits, will say OK. And we're going to get the matches. So you can see that this will be the top level. Anything that was A132 is going to give us that level above it. So here is our top level. In fact, did I do that backwards? I may have. I'm going to real quick just double check to see. Nope, what did I do here? Code. Yeah, I reversed that. That's why. Alright, so what we'll do is we'll match it to the code and do the same thing on this side. So the left code and 2 characters here. And now we should have it. Yes, that's exactly what I wanted to see. Alright, helps to get it the right way, but as soon as I've got it the right way, now hopefully we can start to go through it. So A1, 1 on this side matches to A1, so I'm getting that first level description. And I can rename it so that I know that that's my first level. Now I don't need to keep the value. That's not useful information, so we'll hide that. If I wanted to, I could keep that first level description or the code. I'm not going to worry about the code here. We'll hide that. We will close out the dialog box here. I can even rename these tables, even though it's a copy of itself, but knowing that that's my level 1 table may be very helpful to me. And I'll do the same thing. So I'm going to do this for almost every level of the hierarchy. I'll create the join calculation on this side. In this case, I'll go down 1 level, so we'll still do it on the code. But I'm going to go down, instead of the first 2 characters, I'll grab the first 3. Say OK. And match it up to the code here. And now you can see I've still got my level 1, but now I'm getting my level 2 description. So cereal falls under breakfast, and cheese and milk falls under refrigerated food. Now you'll see some of them, like food, it's matching up with itself, and that's okay. We'll take care of that in a little bit. But once again, I'll hide the fields that aren't quite as useful to me. And I'll rename this one as level 2. And now you can see we're getting close. If I go back and look at the structure here, I have 1 record, but I want only the records that are the lowest level. And here, I do have my levels and I do have my description, but I have records where that description is a higher level. So I need 1 more time to filter it out, the records that I don't want. And I could maybe do some logic, match up the descriptions or something like that. But what I'm going to do instead is just do 1 more join. So I'll do another join to itself. Let's first of all name this level 2, just so we can keep things straight. And I'll do 1 more join. In this case, what I want to do is I want to find out what is that last level of detail. And so what I'll do is I will take the code on this side, and what I want to do is see, does that code match with something at a lower level, or is there something where it has a lower level? So I will create a calculated join here that looks something like this. I'm going to take the left number of digits of that code, and I'm going to take the left number all the way up to the next to last character. And what that will do is that will see if there is a lower level. So if the code matches something where if I stripped off that last digit, so if A1 matches A12, but I take the 2 away, it'll match. Then I'll know that A1 has something beneath it. And that's exactly what I want to know. So this will let me know everything that has something beneath it. I'll make this one a left join because I want to see that happen. And this is lower levels because that is anything that has a lower level. So you'll see food has a lower level, but fruits and vegetables does not. So I'll get nulls on that left join for anything that doesn't, but anything that does have a lower level is not going to be null. So what I want to do is I just want to keep one of these fields. The others I can hide. And all I want to do is keep those null values because that tells me that it's the lowest level of all. And so I'll just call this keep nulls. And if I add that as a filter, and keep only the null values, now I have the exact shape of data that I said I wanted. So if I compared the desired shape here with the shape that I just generated in Tableau, I'll see that I have exactly what I want, and it should work really well for all different kinds of analysis. So let's just double check and see how easy it is to work with. I'll go to a new worksheet. You'll see Tableau organizes things by the table. Sometimes that's really helpful. In this case, I really just want to see all of those fields together, so I'll say group by folder. The keep nulls has to stay there since I'm using it. I can't really hide it or get rid of it, but I could maybe put it in a folder and tell people not to use it. And I can also do something like this. I can create that hierarchy to relationship within Tableau. Just drag and drop these fields on top of each other to create that hierarchy. Bring the description in, and now I have something that I can definitely start to use, and the value makes sense no matter what level of hierarchy I'm looking at. That's the sum total of food. There are the level 2 under food, and I can go all the way down to that lowest level description. Now I've got a shape of data that I can work with, and I can do all kinds of different visualizations with, and it starts to really, really work in Tableau. So lots of different things that you can do in Tableau to shape your data to make analysis easy. Lots of different things that you can do with the features that Tableau continues to add, and all of it starts to allow you to have that power to reshape your data to use it in Tableau. What we'll do now is I see that there are a few questions, and I'll have Bridget come back on the line, and we'll go through. So if you have any questions, we've got a few minutes here, and we'll answer as we can. And if any of you have to drop off, that's totally understandable. We're almost at time, but I want to thank you all for joining us. It's always great to have you here. All right, so first question, is the year population pivot approach dynamic if a new year is added to the data set? And that comes from Matthew. So the way that I showed it there with creating the pivot, that would not be dynamic if new columns were added. You would have to go back in and add that to the pivot there in Tableau. So that's a case where you'll just have to understand how your data changes over time and what you may have to do in order to address those changes. Bridget, do you have anything to add on that one?
No, but I will say that's probably the one big reason why I push so hard for shaping it right, I guess, before you put it into Tableau.
Yeah, definitely if you have that option to shape it first, that can be great because you can create some dynamic processes that will take care of that sort of thing. There is a question from Larry which says, couldn't you just right-click the date field and say show missing values? So I'm guessing that is back on the question of the patients. Yes. Mm-hmm. So if I was looking at that patient data, with the two dates, the issue there is that I have two different dates, and while I can take any one of them and show missing values, so I could take the admit date, and we could show maybe the number of records. If I show it as a bar chart, that's one way that I might want to see something. And then, yes, I do have the option on the drop-down for show missing values, and that does start to highlight the fact that I have more dates in the data set, and that does allow me to fill out all of the values. The problem is that it still doesn't allow me to answer the question of how many patients did I have in the hospital on that given date, because I also had patients that were discharged, and the only way I know that is based on the discharge date. Now, there are ways that you could maybe use some table calculations and then carry forward the values. I know that I've got one person admitted here, and then I could start to bring that forward as a running total or using previous value or something like that, and then check the discharge date to subtract one. It gets really complex. It can be done, and before we had cross-database joins that made it easy, there were definitely times that I did do that. But having the cross-database join and being able to shape the data with one record per date definitely makes that a lot easier. And then you have a lot of flexibility with your visualizations that you didn't have before. So that's a great question. And I guess the final answer is that yes, you could, but I prefer to probably reshape it and make it easier. Oh yes, so Sarah just confirms that the A1, A12, A121 structure, that's very common with MS project data. Yeah, you'll see it there. You'll see it in a lot of government data. Industry codes are often done with that sort of thing. So yes, it is a common pattern, and it goes back to the fact that it's easy to query it and efficient to query it in a database using SQL, but not so efficient to visualize it and analyze it. Will we be sending the recorded webinar to all attendees? Yes. So we're in the process of figuring that out in terms of a process that works well and consistently. But what I will say is check out Technion's YouTube channel, and I'll send a link to that here in just a second, and subscribe there, because that is the first place that these videos get published. I'll send that link as soon as I figure out how. Where can I do that?
If you put it in the comments, there we go. And then we've also got our events page and kind of our blog as well on the new Technion website. So definitely check those out, especially for forthcoming events as well, because I know that's a question that we have as well.
Yeah. All right, Corey's got a great question. Are there open source alternatives to Alteryx out there? Or what other free data shaping tools do you like to use? Bridget, do you have any thoughts around that?
Yeah, I'll go ahead and jump in. So in the past, I've used both, I'm probably going to mess up the pronunciation of this, but KNIME or NEAM, which is K-N-I-M-E, and then also RapidMiner. Originally, RapidMiner 5.3 was free for the community. I do believe they've gone to a pay-per-use model, but I know KNIME or NEAM was free at least a couple years ago. Whether it still is, I can't speak to that. I know my experience with those tools is that they were not as easy to use as Alteryx. I've actually been able to get far more mileage in Alteryx than I have on either of those tools. And then also just in the past, I know I've used Excel quite extensively for a lot of my data reshaping, again, coming from kind of the Excel side of the shop.
Yeah, I'm kind of the same way. If I had to do something other than Alteryx, which Alteryx really just allows, I mean, almost anything that you would want to be able to do, but prior to that, I would do just a lot in SQL Server. So I know that that's not a good answer for what might be free, and that's not necessarily an easy tool to use. But I did like the flexibility that I would have with writing custom SQL or building out different flows of data. There is a tool, and boy, the name has just slipped my mind, which is horrible. But if I think of it, I'll definitely come back to that idea.
One other thing I've got is a comment that says R and Python can be used to reshape data. It does have a steeper learning curve than Alteryx. Thank you, Jose, for that comment. One final piece, too, is that with shaping data, Tableau continues to invest in this area. So Project Maestro is somewhere on the roadmap. They presented it last year at the Tableau conference, and I do expect further presentations and perhaps maybe even, I'm hoping, maybe we get to put our hands on it this year. So that is also forthcoming, and that's Tableau's version of some data shaping within its own product. And I know last year it was quite phenomenal when they were doing the preview.
Yeah, I am definitely excited about that as well. So thank you, everyone, for joining. It is a pleasure, as always, to present to you. We look forward to next time. We will definitely get that invitation out early. I know there were some questions about when it is. We'll finalize that schedule and make sure that everyone who attended today is given an invitation. Thank you so much. Have a great day. Bye.
Thank you.